So today we want to solve a question on wave-particle paradox. All right, here goes the question. A photon of wavelength 6.0 times 10 raised power minus 7 meters behaves like a particle of a certain mass. The value of that mass is Planck constant H is given as 6.63 times 10 raised to power minus 34 joules second, and C is given as 3 times 10 raised to power 8 meter per second. Let's bring out what is given in the question. Our wavelength, which we use lambda to represent our wavelength, 6.0 times 10 raised to power minus 7 meters. Then my Planck constant H is given as 6.63 times 10 raised to power minus 34 joules second. Then my speed of light C, or velocity of light, is 3 times 10 raised to power 8 meter per second. First thing is that recall that the energy of a photon is given as what? One of the famous physics equation, change in mass, which is mc square, right? This is the equation, one of the equation for the energy of a photon, right? Now let's call this equation 1. Also, this same energy can be expressed as E equal to Planck constant times the frequency, right? From velocity, which is speed, is equal to what? Frequency lambda, right? Now if I make frequency the subject, I'll divide both sides by lambda, divide both sides by this, right? So my frequency is equal to what? C over lambda, right? Good. So if I carry everything here like this, I replace it with this F, what am I going to have? Here I'm going to have F C over lambda. Good. This is my equation 2, right? Now compare equation 1 and equation 2. Equation 1 is energy, equation 2 is also energy. That simply means mc square is the same thing as hc over lambda. Good. So what I'm going to have is mc square is equal to hc over lambda. Good. I'm asked to calculate my mass, right? Let me see what is going to cancel.